Hi guys, am I live? Am I audible? Let me know in the chat box. I am back on this channel. Uh, Hi, we are back with another session. But before we start, please let me know if my voice is clear, right? Because sometimes I do get replies where students tell me that we cannot hear you properly or the voice is too low. Let me know. Hi, hello, Yuvanesh. Evening, Sankar. And hi Thaya, hi Aditya. Please let me know my voice is okay because I can see myself on the screen just fine. Just let me know if you can hear me properly also. Please, please, please. Good evening. Hi Adarsh. Hi Purnima. Go and call your friends. We are going to start a very information filled, very crisp session of aldehydes, ketones, and carboxylic acid, as well as amines, right? We're going to complete both of these chapters. Call your friends. We are live. Let's start. Everything is okay. Okay, fine. So, how is the preparation going on? How was the previous session for you guys? Beta, important questions we are going to do tomorrow. Tomorrow, me and Amabita ma'am will do important questions for you guys together. Right now, focus on the theory so that you can solve the questions that we're going to do tomorrow. Perfect, perfect. So I have just another news for you guys. No matter how much theory you do for your organic chemistry, what you actually need is practice questions, right? What questions you're going to practice at this moment? Just your NCRT, whatever is given in the exercise and whatever is given on the in-text question and also the exercise questions, right? And if you want solutions for all the exercise questions, then a PDF link is linked down below where you will get all the solutions for the NCRT, which is very crucial. A very important resource is tagged down below. Please go check it out. Do check it out because it is very essential. All you have to do is do nothing. I will show you once more because theory I will teach you, right? But the practice part you have to do, right? For example, this is my session going on right now. Can you see when I push this more button, what I get here? I get all these notes. Can you see? Class 12 chemistry NCRT solutions chapter wise. Please do not forget to do these solutions by hand or just go through them. Just look at them just once. You can just click on this link and you'll be directed to the Vedantu app. There you just have to log in using your mobile number. That is it. And you will get all the PDFs concerning. Correct? Let us begin this session. I've told you one important resource. Now the next thing is, again, if you're preparing for JEE Advanced or even for the second attempt for the JEE April attempt, if you again want resources, again a PDF is linked down below in the description box. Same, you can go and check it out. At one place, you're going to get all the main material for your JEE Mains and your JEE Advanced preparation. Let us go again. ठीक है? Yes, bacha, only NCRT and this solutions marathon that is going on, that is enough for your board exam. That is a guarantee. Let's move forward. And if you are new here, please subscribe this session also. Please like the session right now. If you haven't liked it yet, please. And let us begin. So, bacha, what I've thought is we will begin by the chapter which is amines, right? Without wasting any time, let's just begin this session. So I will start with the chapter amines. Why? Because it is an easier chapter. It is a smaller chapter. So even though if people are not feeling like finishing the entire marathon with me today, at least you will be done with one of the smaller chapter. Right? Also, I was getting so much more requests about, ma'am, when will you do amines? So we're going to start with amines. Then we're going to move to carbonyl compounds. Okay, let's start with amines. No, bacha, this will complete in 2.5 hours for sure. I know I said it before too, but this is going to take maximum 2.5. I wouldn't stretch it to 2.5. I will keep it to 2 hours. Okay? Let us begin amines chapter. Voice too low? Abhi, is it better? Abhi, is it better? Let me know if it is better now. Please, Abhi, is it better? Let me know, please, with a thumbs up. Let me know if the voice is better. Beta, amines where I'll try to complete it in 30 to 45 minutes. Is it better? Better. Is it better? ठीक है. It's audible. People are saying it's audible. Okay, perfect. Let's not waste any more time because exam is right around the corner. Let's start amines. So what is the first thing that you should know about amines? That these are the derivatives of ammonia. Very, very simple. This is the ammonia molecule, right? And what are amines? These are nothing but the derivatives of ammonia. What I've done, I've replaced one of the hydrogen with R molecule, either one of the hydrogen or two of the hydrogen. Can you see two of the hydrogens are replaced here, or all the three hydrogens of ammonia are replaced in amines, right? So this is a primary amine. This is again a primary amine, but this is an aromatic primary amine. This is a secondary amine. What is a secondary amine? When two hydrogens of ammonia are replaced. And what is a tertiary amine? When all the three hydrogens, can you see this is the ammonia molecule? When all the three hydrogens are replaced by alkyl groups, it is called a tertiary amine. Is this thing clear to you guys? Is this thing clear to you guys? Next thing. Abhi bhi is the voice too low, bacha. I don't think people are not complaining anymore. Please check your mic. Okay? For other people, is my voice okay? Please let me know. Beta, the mic is right. Can you see I'm speaking in the mic itself. Is it better now after I remove this cover? After I remove this cover, is it better? Okay? Correct. Let's move forward. Now, the next thing that you should know about amines is its structure. What is the structure of amine? It is similar as ammonia. Can you see that, for example, here is the nitrogen present, and to the nitrogen, 3 methyl groups are added, and here are the lone pair of electrons present. This is how the structure of ammonia looks like. Does anyone have any doubt in this? What I've drawn here, for example, this is a nitrogen. Here in the p orbital, there's going to be a lone pair of electron. Okay? And here it will be a CH3 molecule. Here it will be a CH3 molecule, and here it will be a CH3. For example, we're talking about tertiary amine. Okay? What all are the things you should know about the structure? That here the nitrogen is sp3 hybridized. Remember this thing, sp3 hybridized. What is the structure? What is the geometry of this molecule? What is the geometry of this molecule? The geometry is pyramidal. Remember this. It is pyramidal. Why? It is not tetrahedral because one on the top it is present a lone pair of electrons. Due to that, the geometry becomes pyramidal in shape, right? And because it is sp3 hybridized, the angle should have been 109 degree 28 minutes, right? 109 degree 28 minutes. But instead, can you see the angle here is just 108 degree. The angle is a little bit less. Why? Because of the repulsion due to this lone pair of electron. What happens? It pushes the angle. It pushes the methyl groups below, and hence the angle decreases a little bit. Therefore, due to the lone pair bond pair repulsion, the angle between this actually decreases. Okay? Okay? Now next that I'm going to do is classification of amines. The next thing that you should know is how the amines are classified, bacha. There are again, as I told you, primary, secondary, tertiary. We've already discussed this, and these are derived from the ammonia molecules. Correct? The next thing is its IUPAC naming, which I've always discussed. Very important. Please do not leave the IUPAC nomenclature. How do you write the common names of amines? We write the common names of amine by just writing the ethyl. For example, the common name of this will be what? Two carbons are there. It means it will be ethane, right? But here the actual common name is ethylamine. For example, here there are 3 carbons, so it will be N-propylamine. For example, here what will be the common name of this? Here can you see that the ammonia, the NH2 molecule is at the second carbon, hence it is called isopropylamine. The common names are extremely important. Right? Now look at this molecule. What is the name of this molecule? It will be, again, write alphabetical wise. For example, here it is the ethyl group, here it is the methyl group. So the name will be ethyl methylamine. For example, here the name will be trimethylamine. Simple. And what will be the IUPAC name? For example, the IUPAC name of this molecule will be to the N. To the end, what will be the parent chain? The parent chain will be the longer carbon chain. Here the longer carbon chain is this. So this will be the parent chain. And to the N, a methyl group is attached, which will become substituent. So the name will be N-methyl ethanamine. Ethanamine is the suffix we use for your amines. Right? Everybody, is this clear? Is this clear to everybody? Right? So please go through all these common names as well as IUPAC name just for your revision. I have attached this slide over here. Now next is preparation of amines. Now we are here how to prepare amines. So the number first method is reduction of nitro compounds. So these are nitro compounds. We have taken nitrobenzenes, right? Nitrobenzenes, we want to make aniline out of it. What I am doing? I am adding hydrogen and removing oxygen. Hence, this is a reduction process because I'm adding hydrogen. Remember this. Okay? So, because I'm reducing, what all reagents can I use? I can use H2 in presence of palladium, or I can use tin in presence of HCl, or I can use Fe in presence of HCl, right? All these kinds of reagents you can use. They do the same work, convert nitrobenzene to aniline. These are all very, very good reducing agents. Tin and HCl, Fe and HCl, very, very good reducing agents. And a very, very important thing written in your NCERT is, like, if you have to choose which reagent is the best, then the best reagent is Fe plus HCl. And why is the case? That is the case because when I put Fe plus HCl together, they form FeCl2. Okay, FeCl2 is preferred because it gets hydrolyzed into hydrochloric acid. What does it do? This FeCl2 gets hydrolyzed into HCl, right? So because this FeCl2 is itself making more and more HCl, it is getting hydrolyzed into preparing more and more HCl. Hence, the quantity of HCl that I actually would need in the reaction would become less because HCl is automatically getting produced in the reaction. Hence, this reagent is preferred over any other reagent to convert nitrobenzene into aniline. Remember this thing. Okay? Shall we move on to the next thing? The next thing is, the next preparation of amines is ammonolysis of alkyl halides. Correct? Very, very beautiful reaction. What is happening in this reaction? Look at this ammonia molecule. What do you see? Do you see a pair of lone pairs over here? Right? And what else do you see? Do you see that we are reacting it with the alkyl halide? What is the beauty of alkyl halide? That this is a very polar molecule with the halide having a delta negative charge and the alkyl having a delta positive charge, isn't it? And we can see that the ammonia is electron rich. Hence, it can act as a very good nucleophile. है ना? क्योंकि बच्चा, I just explained to you today in the morning what are nucleophiles. Nucleophiles are anything that are electron rich. They can either have a lone pair of electrons or a negative charge, right? So it has a lone pair of electrons, so it acts as a very good nucleophile. Nucleophile means what? Nucleus loving, positive charge loving molecules. So ammonia is a positive charge lover because it is filled with electrons, so it attacks this positive charge alkyl over here and forms a substituted ammonium salt. This is the first step. What happens in the second step? Then I add this base inside it, and what I get? I actually get a primary amine. What I got? I got a primary amine. And this primary amine, can you see this primary amine again has a pair of lone pairs on it. So this primary amine again acts as a nucleophile, right? And this primary amine again reacts with more of RX, and it keeps on forming mixed products. What products does it form? For example, the primary amine was formed, then it reacts with more of Rx and form a secondary amine. Then this again react more of Rx and form a tertiary amine. And this again react with more of Rx and finally it forms a quaternary ammonium salt. Is this thing clear to you guys? So in this case, what is happening? We are getting a mixture of products, right? In ammonolysis of alkyl halide, we do not get a single product. We actually get a mixture of products. And you see, from primary, secondary, tertiary, quaternary, we are getting a mixture of products, right? Right? And then next, Bacha, some people are saying to do biomolecules today. I have no time, right? Today we are doing this. Tomorrow, if it's okay with you guys, tomorrow I will plan a session for biomolecules. Okay? Okay? Voice is not coming. Why? I think it's coming. I can hear my voice. See, I can hear my voice. I can hear my voice. Okay? So quaternary ammonium. Yes, bacha, I'm trying to do fast. So quaternary ammonium salt is formed. What other thing you need to know? What is the reactivity order of alkyl halide for this? So the reactivity order of alkyl halide that follows for this reaction is actually Ri is more reactive, then RBr is more reactive, then RCl is more reactive than RF. Remember this thing. Okay? Remember is this thing. Reactivity order, why? Again, because we have to break this bond, right? R and alkyl halide bond. And the easiest bond to break is the bond that is the longest, and Ri bond is the longest. Hence, it is the easiest to break. So the second preparation of amines is over. Let's move on to the next preparation of amines, which is reduction of nitriles. So I'm trying to reduce nitriles, right? And how can you reduce nitriles? By using H2 on nickel or sodium amalgam with your ethanol. Okay, these are very good reducing agents once again. And what you get with this? After reducing, you actually get a primary amine. What are you getting? You are getting a primary amine. ठीक है? And in the back reaction, I want to tell you one more thing. Like I told you that the mixture of products is formed with the ammonolysis of alkyl halides. But if you want just primary amine, then what can you do? Then बच्चा take ammonia in excess. ठीक है? मैं यहाँ I'm writing it here to get just primary amine. What to do? Use ammonia in excess. You can do even this. So these are very, very important points to not miss. Sorry if I missed out. I'm telling you right now. The next is reduction of nitriles. What you do? You are adding hydrogen to both carbon and nitrogen. Hence, it is a reduction process. And what you're getting? You are actually getting a primary amine, basic, simple reaction. The next is reduction of amides. So this is the structure of amide. And when you try to reduce it with LiAlH4, which is a very, very strong reducing agent. Remember this thing. It reduces this CO of amide and forms what? This reduces the CO of amine and adds instead CH2, right? This oxygen gets removed and instead of oxygen, 2 hydrogens get replaced and you get a primary amine product once again. Primary amine product once again. Right? Now the next is Gabriel phthalimide synthesis. Bacha, this is again for the formation of primary amines once again. Once again, primary amines are formed and only primary alkyl amines are formed. Also remember this. Okay? Aromatic amines are not formed. Aromatic amines never form through Gabriel phthalimide synthesis. Remember this point, very, very crucial, important point. So what happens here? We take a phthalimide. Please learn the structure of phthalimide. It looks like this benzene ring with carbonyl groups and an NH group. And then I react it with ethanolic KOH. What happens? Then this H goes away. Why? Because this is a very, very good base, right? KOH is a very, very strong base. So base, what is the function of base? I keep telling people it is a very good. The only function of base is it is a very good proton abstractor. So it will abstract this proton and you will get a potassium salt just like this. Then you react it with alkyl halide. And this alkyl halide can never be aromatic. Remember this thing. Can never be aromatic. They can only be aliphatic. Alkyl halide can be used. And then you get a N-alkyl phthalimide. And after that, you react the N-alkyl phthalimide with a base. And then you get a primary amine as a major product. Okay, all these points are very, very crucial. Very, very crucial to attend. Okay. Next is Hofmann-bromamide degradation reaction. What happens in this bacha Hofmann-bromamide degradation? You take a amide. For again, you start with the amide. Then you react the amide. This is a very, very important name reaction. Please double mark it. It's going to be there in your exam for sure. So Hofmann, what do? You take a amide, you react it with bromine and any base, could be NaOH or could be KOH. And what is the product that you get? You get actually a primary amine. What is happening in real life? What is happening? This whole CO gets eliminated. Correct? This whole CO gets eliminated. Hence, you are getting a primary amine with one carbon less than the reactant. You started, for example, you started with 3 carbon atoms as a reactant, and in product you will get only 2 carbon atom amine. Remember this thing. This gets lost as sodium carbonate. Okay? This is clear to you guys? Okay? Next is physical properties of amines. We have done all the preparations of amines. Okay, what were the most important preparation? Most important is Gabriel thalamine and Hofmann bromamide degradation. These are very, very important name reactions that you have to know. Next is physical properties of amines. What are the physical properties? This is again a screenshot from your NCERT. The lower aliphatic amines are gases with fishy odor. Remember this thing. Primary amines with 3 or more carbon atoms are liquid and still higher ones are solid. Okay? Aniline and other aryl amines are usually colorless, but they get colored when you store them due to atmospheric oxidation. So this is some of the highlighted points that you should know from the NCERT. Okay? Next is we're going to talk about its solubility. What have we learned about solubility until now? We have learned that the lower amines means what? 1 carbon amine, 2 carbon amine. Okay? So the lower amines bacha are soluble in water. And why are they soluble in water? Because the amines can form H bonds. Can you see over here? Can you see over here? The amines can form H bonds. How can they form H bonds? For example, this is the amine RNH2. Okay, RNH2 can form H bonds with the another amine just like this. Okay, so it can form H bonds. That's why H bonds, and hence it is soluble. And which all amines can form H bonds, bacha? Only and only primary and secondary amines can form H bonds. Why? This is the primary amine. What does the secondary amine look like? Secondary amine look like R, N, R and H, right? The secondary amine also has a hydrogen, so it can form a hydrogen bond, right? And what does a tertiary amine look like? The tertiary amine looks like this, right? This is the tertiary amine. Tertiary amine has no hydrogen, hence no H bonding. Okay? Hence tertiary amines are not soluble in water. Okay? Understand these points. What are the other points that you should know? That as the molar mass increases, the solubility in water decreases. Correct? Because as the molar mass will increase, what is happening? The number of alkyl chain is increasing, which is the hydrophobic part. So the solubility will decrease. Okay? Now between amines and alcohols, which are more soluble? Who can tell me? Between amines and alcohols, which one are more soluble in water? Which one has the more solubility? Which one has the more solubility? Amine is NH2 or NH2. Alcohol is ROH. ठीक है? Which one will be more soluble in water? Who can tell me? Who can tell me? Who can tell me? Bacha, we are going to learn about each and everything. We are going to learn about each and everything. Which alcohol? I got the first answer correct. So, bacha, alcohol will be more soluble. Will be more soluble. Okay? Why alcohols are more soluble? Because oxygen is more electronegative than nitrogen. Hence, it will form stronger bonds and stronger hydrogen bonds, and hence its solubility will be much, much more. Correct? Now, next point. Next is the boiling point once again. So when we're talking about the boiling point, again, what did I tell you? I told you that the primary amine looks like this, RNH2. The secondary amine looks like this, RNHR, right? And the tertiary amine looks like RNR and R, right? This is the tertiary amine. So these are the three kinds of amine. Can you see that in primary amine there are two hydrogens? In secondary amine, there is only one hydrogen, and in tertiary amines, there are no hydrogens. Hence, the most of the hydrogen bonding will be present in primary amine, then it will be in secondary, and no hydrogen bonding will be in tertiary amine. Hence, the boiling point will also depend on the hydrogen bonding, right? So, higher the hydrogen bonding, higher will be the boiling point. So, therefore, the order of boiling point will be primary amine will have more boiling point than the secondary amine, and then the tertiary will be the last. Does anyone have any doubt in this? Anyone have any doubt in this? So this is the boiling point order. Primary amine, then secondary amine, and then tertiary amine. Okay? Okay, now next thing. Next is chemical reactions of amine. So whenever you look at the molecule of amine, what all do you see? Now we're going to dissect the molecule of amine. Why are amines reactive? What is the reason behind the reactivity of amines? So do you know amines molecule look like this? RNH2. For example, I'm talking about primary amine right now. So it has what? Can you see that primary amine has a nitrogen and a hydrogen attached to it, right? Amines has a nitrogen and a hydrogen attached, and can you see both of them have high difference in electronegativity? Yes. So due to this high difference of electronegativity, they are actually highly reactive. Number first reason is reactivity is they have high difference in electronegativity. Number second reason of reactivity is they have unshared pair of electron. Can everybody see? Unshared electron pair is with them, right? So due to this unshared pair of electrons, they are very reactive, right? And due to this unshared pair of electron, what does that make the amines? That makes the amine very good nucleophiles. Good nucleophiles. Nucleophiles means what? Anything which are electron rich or which have a negative charge on it are good nucleophiles. So this electron pair actually makes amines as very good nucleophiles. Correct? This thing is clear to everybody? This thing is clear? Yes, bacha, for Hoffman only the major product is enough to mention. Yes. ठीक है? Yes, bacha. Next we're talking about the basic character of amines. Amines has what kind of character? Basic. Why am I saying that once again? Because look at the structure of amines once again. This is the structure of primary amine. What does it have? It has lone pair of electrons. And now go back to the definition of Lewis base. What was the definition of Lewis base? Anything which has a lone pair of electron and can donate its electron are called Lewis base. So can you see, due to the presence of lone pair of electron, they are actually basic in nature. What kind of base? They are Lewis base. Correct? They are Lewis base. So what will happen? How will you know the basic character of amines? I just took a primary amine and then I reacted with some acid. For example, HCl, I reacted it with. Correct? So what will happen? This lone pair of electron will attack this H plus ion. Correct? So when it will attack this H plus ion, it will form a salt structure just like this. Okay? This salt structure will be formed, which confirms the basic character of amine. Why? Because amines are reacting with acid, right? If anything that reacts with acid has to be a base, right? So this is an acid-base simple reaction, and hence a salt is also forming. Therefore, it is a perfect acid-base reaction with the formation of a salt. This confirms that RNH2 amines are actually basic in nature. Next is aniline. So aniline also forms the anilinium chloride salt, which also confirms that even aniline, which is the aromatic amine, is also basic. So both of them are basic in nature. What kind of bases are they? They are Lewis bases. Okay? Now let's compare their basicity with each. Now let's compare their basicity. Now basis, for example, the aliphatic amines. Aliphatic amines, and let's compare the basicity of aliphatic amines and ammonia. And okay, let me write it in some another manner. 1 second. Let's compare the basicity of, 1 second. Let's compare the basicity of RNH2 and ammonia. Which will be more basic? I'm talking about the basic order, basicity order. Which will be more basic? Will it be RNH2 or will it be ammonia? Then, bacha, the answer comes, which is a very obvious answer, which is the amines, the aliphatic amines. I'm once again writing it in words, aliphatic amines. Aliphatic amines are basic in, are more basic than ammonia. Are more basic than ammonia. And why is that the case? Why are aliphatic amines? Because can you see the R group is attached to the amines. The R group is what? The R group is a very, very good electron donating group, right? So this R group is donating electrons to the nitrogen, and hence increasing the electron density on the nitrogen. Hence, the nitrogen is able to donate more electrons, and hence it becomes more basic. Because what was the definition of basicity? That the ability to donate its electron was called the basicity of the ammonia, right? So therefore, aliphatic amines are more basic than ammonia. Now the next is R. Now I'm drawing the another kind of ammonia, which is the aromatic amine. The aromatic amine, which somewhat looks like this. Okay? Now let's compare the basicity of aromatic amine and ammonia. Which one will be more basic? I am looking at the chat box. I'm not telling the answer. Which one will be more basic? Which one will be more basic? Who can tell me? RNH2, aryl amines are less basic. Correct, Rudra. Correct, Rudra is extremely correct, bacha. But what is happening in this case? In this case, this ammonia group is attached to a benzene ring, right? Now, what can happen to its lone pair of electrons? The lone pair of electrons can get into resonance within the ring, right? They can get into resonance within the ring just like this. Hence, due to this resonating structure of its lone pair of electrons within the ring, what happens? The lone pair availability to cause basic reactions, which gives its basicity, becomes less because it is resonating inside the ring. Hence, the availability of the electron becomes less. Hence, ammonia is more basic than your aromatic amines, because aromatic amines, the electrons actually undergo what? Actually undergo this kind of resonating structures. ठीक है, everybody understood this? Everybody understood this? ठीक है. Now we'll talk about more relationship, structure basicity relationship of amines. ठीक है. Now we are trying to compare the basicity of the primary, secondary and tertiary amines. Okay, so before that, let's compare the basicity over in this page. So which will be more basic? I'm writing it here. In gaseous phase. In gas phase, which will be more basic? I'm drawing all the three kinds of amines over here. First, it is ammonia. Next is it is RNH2. Next it is RNR, and then here it is H. Okay, and here next is tertiary amine, which is RNR. Okay, this is the tertiary amine. Now what will be the basicity order? Of course, very easy, because as the number of R groups keeps on increasing, those are electron donating groups. Hence, it is increasing the electron density on the nitrogen atom. Hence, the most basic will be the tertiary amine, then the secondary amine, then the primary amine, and then the ammonia. So, this is the basicity order. This is the basicity order where tertiary is the most basic, then the secondary, then the primary, then the ammonia. But this is applicable, bacha, only and only in gaseous phase. Remember this. This is applicable only in gaseous phase. But as we come on to the aqueous phase, as we go into the aqueous phase, bacha, what will happen? In aqueous phase, I just told you, if I dissolve amines in water, what it will do? It will form hydrogen bondings with water. It has the capacity to do that, right? So, in aqueous phase, what happens? So many factors. Actually, यहाँ पे I'm writing down in aqueous phase. So many factors come into play. First factor that comes into play in aqueous phase is actually the factor called solvation. Solvation means what? Whenever something dissolves in water, it releases some energy, right? And the solvation is the best, is the highest for the smallest atom. As the size increases, solvation decreases, right? The solvation is actually inversely proportional to size. Okay? And as the more solvation means more energy is released, hence more the solvation, more will be the stability. So can you see that as the size increases, if the bulky groups are added much more, then the stability will actually decrease. So number one factor where the aqueous phase basicity of amines depend is the solvation factor. What is the second factor? The second factor is steric hindrance. What it does? Steric hindrance, right? As the bulky groups increases, for example, in tertiary amines, there are three alkyl groups attached. Hence, the steric hindrance increases. Hence, the reactions to carry out basicity actually decreases. The steric hindrance is another factor. And third factor is obviously the plus I effect of the R group, right? The R group is causing plus I effect. So, we have to take into account all these three things when considering the basicity of the aqueous phase. So actually what happens? What order is followed in the aqueous phase? So first of all, let us look at this one. Let's just look at this one. Can you see that here methyl groups are only added? So when I'm talking about methyl amines, right? Methyl amines, only methyl groups I'm adding. So the boiling point, the basicity of secondary amine is the highest, then it is of the primary amine, then it is of the tertiary amine, and then it is of ammonia. Remember this order for the methyl group, and when I change it to the ethyl group, what is happening? Again, the most basic is again the secondary amine, then is the tertiary amine, and then is your primary amine. So this order is followed taking into account all these three factors. Remember this order, very important. It is asked every year, very important question from the aqueous phase. Basicity order is actually different and it depends upon all these factors. Okay? Now next. Next is thank you SV Yuvanesh. Thank you so much. Okay? Next is structure basicity relationship of amines. structure, basicity, relationship of amines. Let us talk about, so we have discussed the aliphatic amines basicity, right? We discussed about the aliphatic amine. For the aromatic, I told you that the basicity actually decreases due to the resonating structures. Can you see that here the electrons are taking part in a resonance, and hence what is happening with the basicity of the aniline or the aromatic amine actually decreases. Okay, and this is again some of the few examples of what, like for example, what is happening over here, what is happening is that a protonation has already happened in this case. So after the protonation has happened, there are only two resonating structures of the protonated structure. Hence, as the resonating structures from aniline decreased after the acid base reaction has happened, hence this is again one of the reasons that the basicity of amines, of aromatic amines, is actually less. So what is the conclusion? Basicity of aromatic amines is less, but the basicity of aliphatic amines is more than ammonia. Is this thing clear to everybody? Is this thing clear to everybody? Now next, we have discussed everything. No, a few things are left. For example, in the aniline structure, this is the aniline structure, right? 1, 2, 3, and here is the NH3, right? So how can I increase the basicity of this molecule, right? So to increase the basicity, what can I do? I can attach electron releasing group on it. Electron releasing group are what? For example, OCH3 group or simple amethyl group. If I attach these kinds of group which are plus I groups or electron releasing group, they will increase the basicity of aniline. Similarly, to decrease the basicity, what can I do? Add electron withdrawing groups to it. So it will even furthermore decrease the basicity, right? So decrease. How can you decrease basicity, bacha? By adding electron withdrawing groups. What are they? For example, the nitro group, the cyanide group, or the SO3H group, etc. Right? All these decrease the basicity of the compound. Okay? Okay, bacha. Let's move on to the next thing. Next is chemical reaction of amines, which is acylation reaction. Okay, what will happen in the acylation reaction, bacha? Can you see this ethanamine over here? So what I am doing here in acylation means what? I am reacting my primary amine with a acetyl chloride in presence of a base. Okay, and here for the acylation reaction to happen, it can happen with only two kinds of amine, which is the primary amine as well as the secondary amine. That is it. Only primary and secondary amines can give the acylation reactions. Okay, and the end product is a N-ethyl ethanamide. N-ethyl ethanamide product is formed. Okay, what I did, I took a ethanamine. This is a ethanamine molecule. I reacted it with a carbonyl, okay, acetyl chloride compound. So what happens? This carbon has a delta positive charge, the oxygen has a delta negative charge, right? So the nitrogen's electron pair actually attack this carbon. Okay, this carbon will get attacked, and what will happen? The HCl will get eliminated out. One of the hydrogen from here and the chlorine from here will get eliminated out, and the final product that you will get will be a ethanamide product. Can you see? A amide is formed once again. So a amide is formed in this case. Similarly, the secondary amine is used over here. In the case of secondary amine, again N-diethyl ethanamide is produced and an HCl molecule is removed. What will happen? These electrons attack the carbonyl carbon, and then Cl will go away from the here and the H will go away from here, and you will get a N-dimethyl ethanamide product. Okay? And this reaction can take place with acetyl chloride or even ethanoic anhydride or even your esters. Even esters give this reaction. For example, if I try to react it with acid ethanoic anhydride, what will happen? This electrons again attack the carbonyl carbon, right? Attack the carbonyl carbon, and then this bond will break off, and this will form a ethanoic acid. This whole compound will form a ethanoic acid, and the rest of the compound that is formed is a ethanamide product. Okay, ठीक है. Next we're talking about the benzoylation reaction. This is again a kind of acylation, but what is happening, instead of the alkyl group, here we have added a benzoyl group. That is it. So I took a primary amine and I tried to react with the benzoyl chloride. There it was acetyl chloride, here it is benzoyl chloride. Again what will happen, an HCl molecule will be removed, and this nitrogen attack this carbonyl, this chlorine will go away, one of the hydrogens will go away, and your amide will be formed, which is N-methyl benzamide. Okay, okay, everybody. Now the next question. Next is carbylamine reaction. In carbylamine reaction, this is a very important reaction. Bacha, what happens in this? You take a primary amine. Once again, this is a test for the primary amine. Only and only primary amines give carbylamine reactions. Primary amines only. Once again, okay? So primary amine, you react with chloroform in presence of a strong base like KOH and heat it. Then you get a very foul smelling. It means it has a very bad smell. Foul smelling isonitrile compound. What do you get? Foul smelling isonitrile compound you get, and only primary amines give this reaction. It could be isonitrile or isocyanide, one and the same thing. They are the name of the same compounds. Okay, this is a test for primary amines once again. Okay, everybody. Next is reaction with nitrous acid. What happens when we try to react it with nitrous acid, bacha? So I took a primary amine over here. I took a primary amine. I reacted with nitrous acid. What did I get? I get a very unstable salt. This salt is very unstable. I took a primary alkyl amine. Primary alkyl amine, when reacted with HNO2 in presence of NaNO2 and HCl, the diazonium salt that you get, this salt is called diazonium salt. It is very unstable when this is the alkyl group. And what happens? This hydrolyzes into alcohol, nitrogen gas and HCl. Okay? But if instead of the primary alkyl amine, you use a primary benzyl amine. What are you using? Primary aryl amine. Aryl amine you are using. In the same reaction conditions, what will happen under around 0 to 5 degrees Celsius? What will happen? You get a very stable benzene diazonium salt, which is the benzene diazonium chloride, right? So you get a stable salt only and only with the aryl compound, aryl amine, and never with the alkyl amine. With the alkyl amine, you get an unstable salt which decomposes into nitrogen and alcohol. Remember this thing. And what is the reason behind the stability of this benzene salt? We will get to know after we see its resonating structures. Okay? I will show you the resonating structures later on, but right now just remember this point. Next is, bacha, what? Next is a reaction with aryl sulfonyl chloride. That is the Hinsberg reagent. Remember, again, there are so many names in both of these chapters. Hinsberg reagent is what? Hinsberg reagent is this. This one is the Hinsberg reagent, aryl sulfonyl chloride. So when I react aryl sulfonyl chloride with your amine, what kind of amine this is? This is a primary amine. So primary amine and your secondary amine, both of these amine, only primary and secondary amines again react with a Hinsberg reagent and forms what? So what will happen? The basic reaction happens. Again, HCl goes away from here. Again, eliminate HCl, right? So only primary and secondary amine gives this reaction because HCl has to be eliminated, and then it gets joined to the entire molecule and you get two kinds of salt. So with the primary amine, you are getting an N-ethyl benzene sulfonamide. Can you see in primary amine, the nitrogen has a hydrogen attached over here. So this hydrogen, bacha, is very acidic hydrogen. What kind of hydrogen this is? Very, very acidic. Why? Why? Because can you see that this is attached to two very good electron withdrawing groups. This O minus, what is this? This S double bond O, S double bond O are very good electron withdrawing groups. Hence, this makes this hydrogen very, very acidic. So, because of the presence of this acidic hydrogen, this is soluble in alkali because the hydrogen is acidic, hence it is soluble in base. But when you are using a secondary amine, there can you see that there is no acidic hydrogen here, no acidic hydrogen after you're using the secondary amine. Hence this salt is not soluble in alkali. Remember this thing. This salt is not soluble in alkali. Okay? This salt is not soluble in alkali. Extremely important reactions these are. Please, please, please keep attention to these things. Only primary and secondary amines give the Hinsberg reagent test. Hence, again, this can be a very, very useful test for distinguishing between the primary, secondary and tertiary amine. This thing is asked every time. I am with every reaction, I'm telling you which reagent gives reaction with the primary amine, with the secondary amine, with the tertiary amine, which reagents can be used to distinguish between all these three. So this is one of the reagent, because with primary amine what is happening, the salt that is forming is soluble in alkali. With the secondary amine there is a salt forming, there is a reaction happening, but it is not soluble in alkali. With tertiary amines there will be no reaction at all. Hence you can use this as a distinguishing test once again with the Hinsberg reagent. Next is the chemical reaction of amines. We are now heading towards to the electrophilic substitution reaction. Okay? Okay? Electrophilic substitution reactions we are now talking about. So what are they, bacha? For example, I just took the aniline. I took the aniline and tried to react it with Br2. Electrophilic means what? Electron loving. है ना? Electron loving. Why it would be electron loving? For example, because this has the NH2 group attached to it. And what is the NH2 group? NH2 is a plus I group. It is increasing the electron density inside the ring. Right? NH2 is a plus I group as well as a plus R group. Plus R means what? That it gives its electron to the ring for resonance. Okay? This is the definition of plus I means electron releasing group. NH2 is an electron releasing group. Also, plus R means what? That it is donating the electrons to the ring for the resonance. Okay? So this makes aniline a very, very active ring. Activated ring means what? It is electron rich ring. Hence, electrophilic substitution reactions can happen. Okay? So, with Br2, what will happen with Br2 and water? What I am getting, this is so reactive. So reactive. What I mean to say, that your aniline, your aniline is so reactive that when you are trying to perform electrophilic substitution reaction, you actually get a tribrominated aniline. Can you see? A tribrominated. You are not getting a monohalogenated product, right? So, to decrease the reactivity of the aniline, because this aniline molecule is very reactive. Hence, as soon as you try to do the electrophilic substitution reaction, all of the ortho and para positions will get substituted. But we do not want that. We want only either ortho or para position to be substituted. We only want a single product. Hence, what we will do, we will decrease the reactivity of the aniline. How we will do that? By actually protecting this group, by protecting this NH2 group. How we will do that? By reacting it with a acetic anhydride in the presence of pyridine. What will happen? This kind of product will be formed. NHCOCH3 will be formed. We have protected the aniline group. Now what will happen? The electrons that were present on the nitrogen will now go into resonance with the carbonyl atom. Can you see? The electrons can now move like this. Right? So the benzene ring is becoming less activated now, because the electron lone pairs present on the nitrogen are used elsewhere, are used here. So because the nitrogen lone pair are used for this acetyl, for this CO bond, hence they are less available for the benzene ring. Hence the activity of the benzene ring is decreased. And now when I try to do the same reaction with Br2 in presence of acetic acid, what do I get? I get the para as a major product. What do I get? I get the para as a major product. And if I want to remove the protected group that I just attached, I can just hydrolyze it in presence of acid and base, and I will get a 4-bromoaniline product. I will get a 4-bromoaniline product. Okay? Next is the nitration. So aniline undergoes so many electrophilic substitution reactions. Number second is nitration. So what is the electrophile in nitration, bacha? The electrophile in nitration is NO2 plus ion. One, again and again tell you the reagent is HNO3 and H2SO4. Right? With this reagent, what happens? This electrophile is generated. And then it attacks the ortho and para position because your NH2 group is ortho and para directing. Remember this thing. Okay? And what kind of product you are getting? Now look at the beauty of the products. Here the para product is the maximum. Okay? We understand because NH2 is is ortho para directing. So we expect the para product to be the major product. But can you see that 47% meta product is also formed? I just told you, ma'am, you just told me that NH2 is an ortho-para directing group. Then why is the meta product forming? So, bacha, is a very interesting case. Very, very interesting case. So, again, I'm forming the molecule of aniline. This is the molecule of aniline with the lone pair of electrons, right? Okay, with the lone pair of electrons. Now, in the presence of acid, what is H2SO4? A very, very good acid. So in the presence of acid, and I already told you what kind of group is NH2. NH2 is a base. It is a Lewis base because it contains electrons. So because it is a base and you are adding a very strong acid like H2SO4, what will happen? This aniline will abstract the proton and will form a anilinium NH3 plus ion. What it is forming? An NH3 plus ion. Can everybody see? In presence of a strong acid, it is forming a anilinium ion. And due to the formation of the anilinium ion, what happens to the benzene ring? The benzene ring now become a meta-directing ring. What does it become? It becomes a meta-directing ring. Okay? A meta-directing ring it becomes. Okay? When, okay, somebody is asking, ma'am, when halogen is substituted with aryl amines, is basicity decreased? Okay. So your question is, ma'am, for example, somebody is asking, ki this is the amine and to the amine you have added a Cl group. Okay. So, bacha, what is the function of Cl group? Cl group actually gives electrons to the ring. Okay, gives electron to the ring through the plus R process. Okay, it will form resonating structures with the electrons. Hence, it is increasing the electron density in the ring. Even though chlorine is called a slightly bit deactivating group, but overall it will increase the ring. It will increase the, the basicity of your ring. Okay, it will increase, but the increase will be least among if other groups are added. For example, other groups are added. For example, like here along with NH2, what I've added CH3. If along with CH3 another group that I've added is NH3 and OCH3, right? So somebody asked the question ki ma'am, if Cl group is added to the aniline, then will the basicity increase or decrease? Then bacha, basicity will definitely increase, but the increase will be lesser than all of these other very, very good plus I and plus R groups. Okay, it will be lesser. Everybody understood this? Now everybody understood this meta-directing process also. This meta-directing process, everybody understood? Let us remove all this stuff which is not necessary. Okay? So why is the ring? So in this case, when you are using a very, very strong acid, you're also getting a meta-substituted nitroaniline and only 2% of ortho-nitroaniline. Okay? Everybody understood the reason behind it? Let's move forward. Let's move forward. The next reaction is again the nitration reaction. Okay? The nitration reaction, the same thing is explained. Now you want to, so here in nitration, multiple products were formed. Now, what you want to do, you want to get only one product. What is happening? I don't want multiple products. I only want one product. Then what will you do? You will reduce the activity of the aniline by protecting the NH2 group, by reacting the NH2 with the acetic anhydride and forming a kind of amide over here. And then now, when the reactivity is decreased with this protective group, this is a protective group which decreases the reactivity of aniline. Now when I try to do nitration with HNO3 and H2SO4, again NO2 plus ion will be generated, electrophile is generated. Now the major product para is formed in this case. Again you can remove the protective group by reacting it with an acid or a base. Okay, everybody understood this? Everybody, yes bacha, I will share the session, surely I will share the PDF of the session. Next electrophilic is substitution reaction is sulfonation reaction. What happens? I took an aniline. Okay, with this aniline, what I'm doing, I'm reacting it with another acid, H2SO4. So I just told you with acid what happens, because this is a very strong acid and your aniline NH2 group is a Lewis base. What will happen? It will do a acid base reaction instead. Okay, the sulfonation before the sulfonation product, a acid base reaction happens and an anilinium hydrogen sulfate is formed, and then when you increase the temperature, then you get a sulfonilic acid, which is a reversible product, which is in equilibrium with the Zwitter ion, just like this. What will happen? This H plus go over here, right? So this is in equilibrium with this Zwitter ion. This is how sulfonation happens. Next is the Friedel-Crafts reaction. What do you think about the Friedel-Crafts reaction? What are the reagents of the Friedel-Crafts reaction? There should be a benzene ring. Now because we're learning about the reactions of aniline, so aniline will be there. And now I want to react the aniline with either the RCl molecule or the RCOCl molecule in the presence of a Lewis acid like AlCl3, right? So this is what? This is a Lewis acid. Now this is how Friedel-Crafts reactions happen, right? Right. Now bacha, anilines do not show, no reaction, do not show Friedel-Crafts alkylation or acylation. It shows none of these reactions. Why? Once again, because this is a base. Aniline is a base, right? Now this base, this electrons, what it will do, this is a base, right? This is a base and this is a Lewis acid. So they will form a acid base salt instead. So what will happen? It will donate its electron to the AlCl3 and instead a salt of aluminium chloride is formed with aniline, but Friedel-Crafts reaction doesn't happen. Remember this thing, because there is an acid present in the reaction. As soon as a very good Lewis acid or a strong acid like H2SO4 is present, then the reactions of aniline will be disturbed. Okay, everybody understood this part? Everybody understood this part? Now the next is the diazonium salt that we are looking at. Diazonium salt, I told you, this is the structure of diazonium salt where N triple bond N is attached to the benzene ring. Okay? N triple bond N is attached to the benzene ring, and this is how diazonium salts are formed. I told you that the alkyl diazonium salt, R N triple bond N, Cl, these salts are unstable, not formed, but aryl diazonium salts are formed. Why? Because can you see that there are so many resonating structures possible of the aryl diazonium salt. Hence, aryl diazonium salts are formed due to the presence of so many resonating structures. ठीक है. Now we're going to look at the reactions of diazonium salts. First of all, how are they formed? I just taught you. How are they formed? I took an aniline and reacted with NaNO2 and HCl at 0 to 5 degrees Celsius. And what do I get? I get a diazonium salt. This is a diazonium salt, right, which is stable in case of benzene. I get a diazonium salt. Now we're going to look at the reactions of diazonium salt. But diazonium salt is a very, very important compound. Why? Because it is helpful in synthesizing so many other compounds that we're going to study. Now that we have made the diazonium salt, we can make anything out of it. For example, I took the diazonium salt and I reacted with it with Cu2Cl2HCl or Cu2Br2HBr or CuCnHCN. Then what are the products I'm going to get? So these are the reactions involving the displacement of nitrogen atom. What happens? The whole N2X is gone. The whole N2X is gone from here. So what will be the final? What will be the final product that we're going to get? We're going to get here ArCl. Here we're going to get ArBr, and here we are going to get ArCN. It gets replaced with Cl, Br, and Cn. And this reaction has a particular name. This is called Sand-Meyer reaction. Remember this thing, very important name reaction once again. Similarly, if I'm using diazonium salt, but instead of Cu2Cl2, I'm using Cu and HCl just that, and Cu and HBr just that, then I will again get product as chlorides and bromides products. Again, I'm going to get, but this reaction is called, bacha, Gatter-Mann reaction. What is this called? This is called Gatter-Mann reaction. Remember this thing. This reaction is called Gatter-Mann reaction, extremely important name reaction. Next is, again, when I try to react the diazonium salt with Ki. With Ki, what do I get? I get a aryl iodide. Okay? Now when I react diazonium salt with HBF4, what product do I get? I get, first of all, this intermediate I will get, and after heating it, I will get a aryl fluoride product. Remember this thing. Okay, so these products I am getting, and what I'm doing, I'm actually cancelling out. I'm actually cleaving the nitrogen bond from the entire diazonium salt. Okay, so again what to do? The next reagent with the diazonium salt is the H3PO2H2O and your CH3CH2OH. With both of these reagents, the end product is a pure benzene ring. That is it. What do you get? You get a benzene ring with these reagents. Next is again your ArN2Cl, and with H2O, what you are doing, bacha? With H2O you are adding, now you are getting a alcohol attached to it. Okay? With H2O you get a phenol. What do you get? You get a phenol product. Okay? Now the last reaction, okay, I've already taught you this. No. So N2BF4, that is formed here. The N2BF4 was formed even here, right? So when I just heated it, I got a fluorobenzene ring over here. But now I am heating it. What I'm doing, I again took the diazonium salt. I reacted with HBF4, which is fluoroporic acid. I got this kind of salt. Now when I reacted with NaNO2 and CO and then heated, then the product that I'm going to get is a nitrobenzene. Okay? These are important reactions, can be as easy and important. I love this chapter because these have the very most important reactions and also the easiest of them all. Okay? Very interesting chapter. Next is the reactions involving retention of diazo group coupling reactions. Right? Now we are looking at diazonium salt and we are trying to couple it with other things. The other things, for example, with a phenol or with the aniline. Okay? The major important part is that at the para position there should be a presence of a hydrogen atom. Can everybody see? At the para position there is a presence of the hydrogen atom, and at the end, so with the phenol in the presence of the base the reaction happens, and with the aniline in presence of acid this reaction happens. Okay? And what happens, bacha? Here this HCl goes away. Here also this HCl is eliminated. Okay? And the final product that you get is a dye product which is called para-hydroxyazobenzene. What do you get? You get a azobenzene in both the cases. Here you get para-hydroxyazobenzene. Here there is para-amino-azobenzene, and you should know the color of these dyes. The OH is the orange dye. Oh, obviously it starts with O, and the the color of the dye is also O, orange. And this is aniline. Aniline is always a yellow color dye. Everybody got this? Everybody got this? Next. Okay. Okay, so you didn't even realize when we completed the entire amines chapter. I didn't leave even one thing. Some uses might be remaining, but in this chapter, I don't think I've left anything. The entire amines chapter we have completed within 1 hour. Wow, wow, wow. So you completed the entire amines chapter. The next thing that you have to do before coming to aldehydes, ketones and carboxylic acid, I am again want to remind you, please, please, please do all the exercises and all the questions. So do not start solving right now because it's going to take so much of more time. Just look at the solutions to whatever is already provided. You just need the right resources, and we have the right resources which is linked down in the description box below. You can always go and check out the chapter wise solution to each chapter which is given down in the PDF below. Please download it and don't forget to do all the questions. Now let's start aldehydes, ketones and carboxylic acid chapter. Are you guys ready? Are you guys ready for this chapter? Let us go. Next. So the aldehydes, ketones, carboxylic acid contains so many things, and what do their structures look like? We have to know. So the aldehyde actually looks like this. The aldehyde has a, okay? The aldehyde, okay, is a, beta, right now I cannot give you break. We'll just finish this and then you can get a break because we already took a long break. I ended the first class at around 5 p.m. and now I'm here again at 9 p.m. Okay? So this is what the aldehyde looks like. This is what a ketone. Aldehyde has what? Both, every molecule that we are going to study in this chapter will have a carbonyl group. This carbonyl group will be common everywhere. Just that the alkyl groups attached to it will keep on changing. For the aldehyde, one is the alkyl group, the other will always be a hydrogen group. For the ketone, both of them will be the alkyl group. For the carboxylic acid, one will be the alkyl group, the other will be the OH group, right? For the acyl halide. Now, after this, after the carboxylic acid, whatever functional groups you are seeing, these are all derivatives. What are these? These are all derivatives of carboxylic acid. Remember this. These are all derivatives of carboxylic acid. For example, this is acyl halide. I have replaced the OH with X. This is acid anhydride. I have replaced the OH with another RCOO group. And then ester is what I've replaced the OH with OR group, and the amide is, I've replaced the OH with the NH2 group. Right? Right? Will nitrobenzene give the coupling reaction? What nitrobenzene? Beta, only this benzene. Nitrobenzene, bacha, can give the coupling reaction. Yuvanesh is asking. Of course it can give. What you have to do? The nitrobenzene looks like this, right? Just use a little bit of your brain. Nitrobenzene looks like this. Then just reduce this. Reduce this by using tin HCl or whatever. When you reduce it, you will form an aniline, right? You will form an aniline, and from the aniline you get a diazonium salt. After getting a diazonium salt, you can form a coupling reaction out of it. So of course nitrobenzene will give the coupling reaction after following all of these steps. Directly, no. Directly it will not give. Only the reaction mentioned here will give the coupling reaction. Okay? Okay? Beta, I will try to complete it in 1 hour. Okay, so these are derivatives of COOH. Okay, people are asking a lot about the biomolecules session. Beta, I don't have the time right now. You can already see that I'm back-to-back taking sessions. So before your exam, probably tomorrow in the morning, I will try to do biomolecules. We can do biomolecules around 12 p.m. Is that okay with you guys? If we start at 12 p.m. to do biomolecules tomorrow, maybe I'll plan a session. ठीक है? ठीक है? Next, you understood. Now we're trying to look at the structure of the carbonyls. ठीक है? Sorry, right now let me have some water break. So probably I will ask a poll, and then if so many students are interested in biomolecules, we're going to do a biomolecules. Don't worry about that. Beta 10 a.m. it's 12 p.m. I can start. 10 a.m. will be too early for me because I have to go home. Yes, bacha, I will complete the biomolecules within 1 hour. That is the promise. 1 to 1.5 hours. That is it. 1 to 1.5 hours, we're going to complete biomolecules, and I'm going to do it tomorrow. Right now, let's focus on structure of carbonyls. So, bacha, what happens in this structure? Can anybody see? Can anybody see what is the structure of carbonyl looks like? There's a carbon, okay, and the carbon is attached to two R groups over here, or whatever groups are here, can be R, can be H, and then it has a p orbital over here, right? And the third bond is connected to a oxygen, and the oxygen also has a p orbital over here, right? And now the p orbital overlap to form a pi bond. This is how a double bond is formed, correct? And what is the angle between the carbon here bacha is sp2 hybridized, right? So because the carbon is sp2 hybridized, the angle here will be 120 degree. That is obvious. So this thing you should know, that this is the structure, right? This is the structure. So one is the pi bond, one will be the sigma bond, right? The angle here will be 120 degree. The carbon here is sp2 hybridized. Okay? And what are the other things that you should know about the structures? That also I'm going to tell you. The other things that you should know about the structure is this. One second. Yes, the other thing is, this is the carbonyl molecule. Everybody, right? This is the carbonyl molecule. Now the oxygen here has a delta negative charge, isn't it? The carbon here has a delta positive charge. Why? Because oxygen is more electronegative. It will pull the electron towards itself and hence get a negative charge, and carbon will get a delta positive charge. Everybody understood this? Now, because this gets a delta positive charge, hence this acts as a very, very good, because it has a positive charge on it. Hence, it gives electrophilic reactions. What will it give? It will give electrophilic reactions, and similarly, your oxygen here has a delta negative charge. It has a negative charge on it. Hence, it will attract neutrons towards it. So, it will give nucleophilic reactions. Right? So, all these things you should know about. Okay? You should know about all these things. Okay? And due to this carbon, which has a positive charge, it acts as a Lewis acid. Right? It acts as a Lewis acid because it is attracting electrons to itself. And due to the oxygen, which is electron rich, right, which has a delta negative charge, it acts as a Lewis base. So it has a polarity of both the things. It can act as a Lewis acid as well, also as a Lewis base. Okay, everybody understood? And therefore, this CO bond is extremely polar bond. So all these things are very, very essential to know. First of all, the carbon here has a delta positive charge. Oxygen here has a delta negative charge. Due to that, oxygen gives nucleophilic reactions. The carbon will give electrophilic reactions. The carbon will act as a Lewis acid. The oxygen can act as a Lewis base. The CO bond is a polar bond and has a dipole. Okay? Next is preparation from alcohols. What are the preparatory methods? So, what are the preparatory methods from alcohols? You're making aldehydes or ketones. So, bacha, the primary alcohols are oxidized to aldehydes. Remember this thing. Whereas the secondary alcohols are oxidized to ketones using suitable reagents. And the tertiary alcohols can never be oxidized. Remember this thing once again. Tertiary alcohols can never be oxidized. Primary alcohols convert into aldehydes. Secondary alcohols convert into ketones, correct? So for example, the reaction goes like this. This is a primary alcohol. When I try to oxidize it, the first step after oxidation is an aldehyde, and when I oxidize it even more, the last step is a carboxylic acid, right? The last step is a carboxylic acid. Hence, if I use a very strong oxidizing agent, for example, KMNO4 or K2CR2O7, if I use strong reagents like this oxidizing, the alcohols will directly convert into acid. But if I use milder reagent, then I can stop the reaction in between. Okay? Now what are those reagents? Let us look them one by one. Number first reagent is PCC, PDC or Collins reagent. PCC is pyridinium chlorochromate. PDC is pyridinium dichromate. Okay, what do these do? These oxidize the primary alcohols and the secondary alcohols, so ketones, to aldehydes and ketones respectively. Okay, these are mild oxidizing agents, so they stop the reaction at the aldehyde or the ketone part. They do not get oxidized directly to acids. Correct? So for example, here this is a secondary alcohol, right? Secondary alcohol, so it gets converted into a ketone. Next is KMNO4, K2CR2O7 and Jones reagent. So what will these do? So these oxidize secondary alcohols. Always remember that KMNO4, K2CR2O7 oxidize primary alcohols directly to acids, right? But the secondary alcohols get oxidized only to ketones. They cannot get oxidized to acids. So with KMNO4, K2CR2O7 and Jones reagent, the secondary alcohol gets oxidized into ketone. Next is the preparation of carbonyl compounds by ozonolysis of alkene. Extremely important reaction. Correct? Very, very beautiful reaction. For example, here I took an alkene over here and I try to react it with ozone. Okay? And then what will happen? An ozonized structure is formed. Just look at how the structure is formed. Just remove both the double bonds from between. Wherever the alkene is present, just remove that double bond and then form bonds with oxygen, with all the three oxygens of ozone, just like this, and then try to break them just like this. Okay, what is mentioned over here, and the products that you will get are RCHO and HCHO products. That means that you actually got, in the presence of zinc and water, the products that you got are aldehydic products. So how to predict the product? By just looking at the alkene, I will tell you a very simple format. Just break this bond first. For the ozonolysis, predicting the product of ozonolysis, just break this bond from here. Then what will you do? Just add double bond O here and a double bond O here. That is it. That is your entire reaction. So can you see? This is forming RCHO. This is forming HCHO. Correct? So this is your entire product. And similarly, if I try to do ozonolysis for this, what will happen? Can you see here that a tertiary carbon is attached, and to the tertiary there is a double bond attached over here. So how will you predict the ozonolysis product? Once again, break this bond. Break this bond. What did I teach you? Ki here just put a double bond O over here, and here again put a double bond O over here. So what are the products that you can expect? Here a ketone is formed and here an aldehyde is formed. So what is the analysis after this? That a tertiary carbon actually forms a ketone, whereas a primary carbon forms a aldehyde. Okay? Primary carbons form an aldehyde, or the more best way to put it is unbranched alkene always forms an aldehyde, while as a branched alkene forms a ketone. This is a better analysis. Better conclusion is branched alkene forms a ketone. Okay? Next is by ozonolysis of alkene, you must know the difference of the reagents. Just look at the reagents and know the difference. For example, here, what did I do? What did I do here, bacha? I took an alkene, okay, and I tried to do ozonolysis in both the cases. But here I took water as a solvent, and here I have taken zinc and H2 as a solvent. And due to the solvent, the last products will change. As I'm changing the solvents, as I'm changing the hydrolysis process, the product will change. For example, here again the ozone lysis product was what? Just break this bond from the middle and add double bond O over here and double bond O over here, right? This was the product that I told you. So with ozonolysis and zinc H2O, this same product is got, which is a ketone product and an aldehyde product. But when you are using water as a hydrolysis medium, then bacha, your aldehyde gets converted into acid. Can you see? The ketone remains as such. The ketone remains as such and the aldehyde gets converted into the acid. Okay, the ketone remains as such, can everybody see? But the aldehyde gets converted into acid when you use the reagent as H2O. H2O. Okay. Next is acid catalyzed hydration in presence of mercuric salt. ठीक है, acid catalyzed hydration in presence of mercuric salt. You took an alkyne. This reaction is given in your NCERT. All the reactions of teaching given in your NCERT. And this reaction follows Markovnikov addition. What happens is you are reacting the alkyne with HgSO4 H2O in presence of H plus. Then OH will be added to the more substituted alkene, which is this. More substituted alkene without carbocation formation. Without carbocation. No carbocation is formed. Hence, no rearrangement will take place in this kind of mercuric acid wala thing. Okay? And then the OH. So, what kind of product is formed? An alkenol product is formed. Can you see alkenol? This can undergo tautomerization. What happens in tautomerization? What happens in tautomerization? This can go here and this protonation can go here, and the product that you will get is a ketone product after tautomerization. Okay? The next is acid catalyzed hydration in presence of mercuric salt. This is how the reaction takes place. What is happening in here, bacha? In this, if you are taking the reactant as a ethylene, if I took the reactant as ethylene and I try to react it, then the product that I will get is a aldehyde product. Otherwise, with all the other kinds of alkynes, you will always get a ketone product. Remember this. In the acid catalyzed hydration presence of mercuric salt, only and only with ethylene, you will get the aldehyde product. Otherwise, with all other kinds of alkene, you will get a ketone product. You can form the products by your hand and look at them by yourself. Okay. Next is the Rosenman reduction. Again, a very, very important name reaction. Extremely important name reaction from acyl chloride. Rosenman reduction we are talking about. Rosenman reduction. So what I took benzoyl chloride and I reacted it with hydrogen and PDBaSO4, and what I actually got benzaldehyde as the product. Extremely important name reaction. Okay? You take a benzoyl chloride, react it with hydrogen, palladium BaSO4, you get a benzaldehyde. In the end, bacha, what is happening? Reduction is happening. Why? Because can you see here, you are adding hydrogen in the final product. Hence, this is a reduction reaction. Rosenman reduction, name reaction. Next is preparation of aldehydes. You can form aldehydes from nitriles and esters. What did I do? I took a nitrile and I reacted it with SnCl2 and HCl, and what I got a imine product. What is this? This is a imine RCH double bond NH. What did I do? I did nothing. So this was the RCN molecule, right? This is the RCN molecule. Now I added 1H over here, 1H over here. And after hydrolyzing it, what product am I getting? I am getting a aldehyde product, RCHO. This is again a name reaction called Stephan reaction. So all these reagents are important. For Stephan reaction, it is again a reduction reaction, right? And what you are getting, bacha, the reagent used here is a tin chloride and HCl, right? Next is from nitriles and esters. Right? From nitriles and esters, another reagent that you can use is a Debal H reagent. What is Debal? Debal is dibutyl aluminium hydride. Dibutyl aluminium hydride or diisobutyl aluminium hydride is the reagent. What did you do? You took a nitrile group and you reacted it with aluminium, with Debal H reagent and in the presence of H2O. And what did you get? You get a RCHO product. Again, an aldehyde product. Similarly, you reacted this with the same, you will get an aldehyde product. Similarly, esters can also react with Debal H and you will get again an aldehyde product. The bond will break from here. Right? You will again get a aldehyde product. Is this thing clear to everybody? Okay? But it will not affect the double bond. Can you see? That's why this is included. Debal H will not affect the double bond. It is only when only affecting your nitrile group, not affecting the double bond at all. Okay. Next is from chromyl chloride. Just see, just look at the toluene over here. And now I'm using the reagent chromyl chloride in presence of CS2 and I'm getting a chromium complex, and when I'm hydrolyzing it, the final product that I'm getting is a benzaldehyde. This is again a named reaction called Etard reaction. In Etard reaction, what you are doing, bacha, you are oxidizing a toluene. What you're doing, this is an oxidizing agent. Chromyl chloride you're using in presence of CS2 and the final product you're getting is a benzaldehyde product. Okay. Next, again, another reagent that you're using is a CrO3, which is chromic oxide reagent. And again, you're reacting toluene with chromic oxide and acetic anhydride. What you're getting is this complex, and then when you hydrolyze it, you again get a benzaldehyde. You again get a benzaldehyde. Is this thing clear to you guys? Is this thing clear to you guys? Now, next is by side chain chlorination followed by hydrolysis. What you're doing, you took a toluene and you're trying to do side chain halogenation. As I told you in the morning, this reaction we read in haloalkanes and haloarenes, that where will the Cl, chlorine, attack? The chlorine will attack because it is a free radical mechanism. It will attack the most stable free radical, which is this. So the chlorine gets attached to this benzylic free radical, and then we'll get a benzyl chloride, and after the benzyl dichloride is formed, we can hydrolyze it to get benzaldehyde. These are important name reactions given in your NCERT. Nothing I'm teaching you outside of the syllabus. Please know all these reactions. Next is again a very, very important name reaction, Gattermann-Koch reaction. You take a benzene and react it with carbon dioxide, NHCl, in presence of anhydrous AlCl3 and CuCl. The thing that you get is a benzaldehyde. Okay? You get a benzaldehyde as the product. Is this thing clear to you guys? Next is from acyl chlorides. Again, these reactions are extremely important. You took a Grignard reagent. Reacted with CdCl2. The product that you got is a R2CD. Now you react this R2CD with acyl chloride and the product that you get is a ketone. Now we are reading about the preparation of ketone. This is the first preparation of ketone from acyl chlorides. Next is from nitriles. Again, you react nitriles with your magnesium bromide, which is RMgX ether, and the final product that you get is again a ketone. Again, extremely important reaction. You're doing nothing in this case, just reacting the product. See, this act as a delta positive, right? This act as a delta positive. Hence, everything gets attached over here. This R gets attached over here, and to the N, the MgBr gets attached, and this gets lost after the hydrolysis and gets converted into ketone. Extremely simple reaction. Next is Friedel-Crafts acylation reaction. So Friedel-Crafts acylation or Friedel-Crafts acylation happens with the benzene that you've already learned, and what is formed at the end? At the end, a acetone group is formed once again. Okay? Now the physical properties. In the physical properties, you should know that methanol is a gas, ethanol is a volatile liquid. Other aldehydes and ketones are liquid or solid at room temperature. Okay? This is the basic point. Now we're talking about the boiling point. Boiling point, what you should know in the boiling point, bacha. The boiling point is the boiling point of the aldehyde, which is a CHO group, or a ketone group, right? Are the boiling point of aldehydes and ketone is higher than ether. Remember this. They are higher than ethers. Why? Because they have what, bacha? They are polar molecules. I just told you. They are polar molecules, hence they have dipole interactions between them. They have dipole interaction. Okay? So due to the dipole interaction, what do? They actually form weak associations with each other. Hence, they are a little more difficult to break than an ether. Hence, they have higher boiling points than ether. But their boiling points are lower than alcohols. Why? Why are they lower than alcohols? Because alcohols can form hydrogen bonding, while your aldehyde and ketones cannot form hydrogen bonding. Remember this thing. They cannot form hydrogen bonding. Okay? Now next. Next is solubility. When we are talking about solubility, what is the thing that we should consider? What is the first thing that we should consider when we are talking about solubility? That do they form hydrogen bonding? Yes, they do form hydrogen bonding. This is the first thing that you should know, that the lower members like methanol or like ethanol, CH3CHO, methanol, ethanol, or even your propanol. So these are the lower members, right? Lower members are absolutely miscible in water. They're very, very miscible in water. Remember this thing, they're very, very miscible in water. Why? Because they can form H bonding. Can you see the H bonding is formed over here? Hence, they are very, very miscible. But as the size increases, solubility decreases. That is the thing. Solubility decreases, right? As the size increases, solubility actually decreases. Next is the nucleophilic addition reactions that we're going to talk about. Okay, the nucleophilic, have I left any space? Yes, I've left some space. The nucleophilic addition, I just told you. What did I tell you? Because the oxygen here is so much more electronegative, hence it will get a delta negative charge. Carbon will get a delta positive charge. Now because carbon is delta positive, because it is positive, so I can attract a negative species to me. Negative species is a nucleophile, right? So this carbon will show what kind of reactions? Nucleophilic reactions. Remember this thing. And this thing happens all in a plane, because this carbonyl group is sp2 hybridized. Now as soon as the nucleophile attacks, the planarity is disturbed and a tetrahedral intermediate is formed of the alkoxide. This alkoxide tetrahedral intermediate is formed. Now with the H plus, again if we give to this, what will happen? It will form this kind of structure, which is again a tetrahedral sp3 hybridized structure. So from the sp2 hybridized structure, we are getting a sp3 hybridized structure whenever we are doing nucleophilic addition reaction. What we're doing, we're not substituting, we're adding one more thing to that, right? So we are doing nucleophilic addition reaction. Now let's talk about the reactivity order. So I'm going to tell you that the aldehyde group is actually more reactive, for nucleophilic addition reaction. So ma'am, why are you saying that? Why do you think this is the okay, let me draw this C double bond O, here is the H, and here somewhere will be the R group, right? This is the aldehyde group, and I'm again drawing the ketone group over here. Ketone is R group to the both the places. Okay? So I am saying that aldehyde, among aldehyde and ketone, aldehyde is more reactive towards a nucleophilic addition reaction than the ketone. Why is that the case? The reason is both. The reason, bacha, is both steric and electronic reasons. Both steric and electronic reasons. Okay? What I'm saying, nucleophilic means a nucleophile will come and attack. It will attack where, bacha? It will attack this carbon. Okay? Now, if there are too many bulky groups present, for example, in ketone, can you see two big alkyl groups are present, hence the attack of the nucleophile will not be that great as compared to the aldehyde, because in aldehyde there is one hydrogen is present, one chotu atom is present, one smaller atom. So the attack will be easier on the aldehyde group for the steric reason. Now, what are the electronic reason? So, bacha, can you see the alkyl group attached to the carbon is actually an electron donating group, and to the ketone two electron donating groups are attached, right? Now, electron donating means what? It is increasing the electron density on the carbon, but I want the carbon to be delta positive. For the nucleophilic addition reactions to happen, I actually want carbon to be more positive, right? To be more positive. Only then better kind of nucleophilic addition reactions can happen. Hence, nucleophilic addition reactions happen better for the better, more reactive is aldehyde than a ketone due to both steric and electronic reason. Is this thing clear to everybody? Is this thing clear to everybody? ठीक है? Thank you, Gayatri. Beta, somebody is asking, ma'am, how van der Waals forces affect the boiling point. Bacha, van der Waals forces, as the van der Waals forces increases, the boiling point also increases, because van der Waals forces depend upon the mass of the molecule. And as the mass increases, van der Waals forces increases. And if the van der Waals forces, which means the interaction between the molecule is increasing, which means the boiling point will also increase. Correct? Now, next is we are going to study the nucleophilic addition reactions. What are they? So, number first nucleophilic addition reaction that we are going to study is the addition of hydrogen cyanide, the HCN reaction we are going to study. Right? So, I am adding HCN in presence of OH negative ion. Right, and I'm getting a Cn minus ion. Why? Because OH negative is a base, and the base will abstract the proton H plus from here, and I will get a Cn negative ion. So Cn negative is now my nucleophile. This nucleophile will attack the carbonyl carbon, and I will get a tetrahedral intermediate just like this. Now, after giving the proton, I will get a cyanohydrin structure just like this. This is one kind of, from the sp2 carbon, I'm getting a sp3 hybridized addition reaction by HCN. Next is addition of sodium hydrogen sulfide. So after adding sodium hydrogen sulfide, what I can do? What I can do after adding sodium hydrogen sulfide? Okay, I will just add. What can happen with sodium hydrogen sulfide, bacha? Again, to the carbon, what will be added? The SO3H minus. The SO3H minus will be added to the carbon, and to the oxygen, the Na will be added, which is the positive thing. Right? And after the proton transfer, the Na will go away and the OH will remain here, and the bisulfide addition compound, which is a crystalline compound, will be formed. Next is addition of alcohols. Very, very important reaction. You also see this reaction in your biomolecules chapter. Right? So this is the RCHO molecule. Correct? This is the aldehyde molecule over here. And when you react it with ROH, which is the alcohol, in presence of dry HCl gas. In the presence of dry HCl gas. Right? So what happens, bacha? Here a hemiacetal is formed. So to the carbonyl. So this is the this is how the carbonyl atom looks like. CO, here it is the R, and here it is the H. Right? So this is the aldehyde group over here. Now the R-OH I want to attack. Now if I want to attack the R-OH group towards it, what will happen? What will happen? An hemiacetal will form. Correct? So here the OH will attack. Here the OH will attack. And here the R will attack. Okay, hemiacetal is formed, and after giving it proton, a direct acetal group is formed. Okay, next if I took a ketone, and a diol. Oh my god, what is happening to my brain? I have used it too much today. So a diol and a ketone is over here, right? And I try to react with HCl gas. The product that I get is ethylene glycol ketone. How to remember the product, ma'am? Okay, I will tell you an easy method. This doesn't happen, क्या बोलते हैं? through mechanism way. This doesn't happen, but just to remember it, just remember that I have to remove H2O molecule, remove oxygen from here and 2 hydrogens from here, right? So this will be the entire product that will be formed. After you have removed the H2O molecule, you will get a ketal molecule. This is not the correct way to depict the mechanism of the reaction, but to remember the product formation, you can remember this method. Similar case will happen with aldehyde. Bacha, with aldehyde, you get an acetal form just like this. From the aldehyde, you first get the hemiacetal, then you get acetal. But from a ketone, you directly get a ketal product. Okay? Next is addition of ammonia and its derivatives. Can everybody see? I took a carbonyl group and I took a ammonia, and to this NH2 some Z is added. The Z can be anything. The Z here can be an alkyl group, can be an aryl group, can be OH NH2 or a C6H5NH or a NHCO NH2, could be any group. And what am I doing? I am again making the final product. I'm again telling you, just remove H2O once again. The final product. This is not the correct way to look at the reaction, but to predict the product, this is the best way to predict. See, after I remove the H2O from here, I will get C double bond N Z product, and this is the final product that you're getting. So before that, an tetrahedral intermediate is formed where OH is over here and NHZ is over here. Correct? Now the Z, what can be the Z's and what will be the derivatives out of it are all written over here. Okay? Ma'am, when is class for everybody is asking for biomolecules. Okay. Beta, I will take the class tomorrow 12 p.m. for sure for biomolecules. I've gotten so many requests for now. For 12 p.m. tomorrow, I want everybody to be here and I will take the biomolecules class. Okay? Biomolecules class tomorrow 12 p.m. Next is, now we are back to aldol condensation. So this is the class that I did very recently. So if you want to look at these reactions, I did it very recently from all the name reactions chapter. So I have attached all the name reactions over here. From now on, all the name reactions are there. For example, aldol condensation, cross aldol condensation. For example, intramolecular aldol condensation, Cannizzaro reaction, cross Cannizzaro reaction, Clemmensen reduction, Wolff-Kishner reduction, and what is the difference between the Clemmensen and the Wolff-Kishner reduction? What is Hell-Volhard-Zielinski reaction? So all these reactions are included in this. Okay? But I've already taken just a week before I took a class based on the name reactions. And you have to definitely see that video because name reactions are so important from the point of view of your board exam. You can go and check it out. Otherwise, you will get the notes in the PDF for sure. And I will take your leave from here because aldol, Cannizzaro, everything I've already taught my students just a week before. Okay? Thank you so much, guys. And if you want to learn aldol Cannizzaro right now, you can tell me in the comment section. Otherwise, it is already about to be 11. We can call it a night. We can call it a night. Okay? Okay? So all these, if you want, there is a session that I took which consists of all the name reactions of organic chemistry. So I took 2 sessions of it. Each session is around 2 hours each, not even to 1.5 to 2 hours each. You can go and look at that session and all the name reactions are included there. Thank you everybody for attending the lecture. I will see you tomorrow with biomolecules. Thank you so much. Please like the session. You guys don't like the sessions. How many students are viewing this session right now? The likes ratio does never match. Why are you not liking the session? Do you not like me? Or what are you not liking? Then please let me know in the feedback box below. Thank you so much for attending the class. I will take your leave. Take care. Bye-bye. Bye-bye. Thank you.